Okay, guys, we're continuing on with section 3.4. We're going to be solving rational equations again today. These are going to be a little more difficult because we're going to hit up problems where the denominators can be factored. So the first thing we want to do is factor any denominators that we have. This x squared minus 4, as we recall from the million times that you've factored already, is called a difference of squares, and that can be factored as x plus 2 and x minus 2. Now, once that's factored, we can worry about what the LCD is. So we look at the actually, let me go over here as well. The first one can also be factored. It has a GCF of 3, and then 3x divided by 3 is x, 6 divided by 3 is 2. Now that everything is factored, now we can go ahead to our LCD. Remember, everything has to get represented. So the 3 right here, that'll go with my LCD. The x plus 2 right here and here, even though it appears, it's only once in each, so only put it once in your LCD. And then we got an x minus 2 here and here. It's only once in each fraction, so only put it once in your LCD. So our LCD has 3 parts to it. Our next step is to multiply everything by the LCD. I'm going to save you a little bit of time and space here. What you can do is just look at what's missing here. Like in the LCD compared to this, what is in the LCD that is not appearing here? The only thing that's there that's missing is x minus 2. So a shortcut that we're going to use is we're going to multiply the 2 on the top by this x minus 2. So we're going to distribute that. 2 times x, 2 times negative 2. Okay, now we're going to look at the second one. The first fraction's done. The second one with the 1 on top, we look, what does the LCD have that this doesn't? The only thing missing is the 3. So the 1 in the numerator is going to multiply by the missing 3. So 1 times 3 is 3. And then finally, after the equal sign, what are we going to multiply by the 4 by? So we look, what's here that is missing here? So what's missing is 3. So we're going to put times 3. And we're also missing x plus 2. So we're going to also multiply by x plus 2. So we're going to do 4 times 3 is 12. Then we're going to distribute 12 with x plus 2. So 12 times x, and then 12 times 2. So now we have a very simple equation that we can solve for x. On the left, minus 4 plus 3 is minus 1. Now we have variables on both sides. We're going to subtract 12x from both sides. Then we're going to add 1 to both sides. And then we're going to divide both sides by negative 10. And we'll call it negative 2.5. Okay, it does say solve and check, so now we're going to check our solution. This is called checking for extraneous solutions. So we're putting back negative 2.5 in for the x's in the original problem. Just clean that up. So in the first fraction, that'll be 2 over 3 times -2.5 is -7.5. And then -7.5 plus 6 is -1.5. And then -2.5 squared, that's 6.25. 6.25 minus 4 is 2.25. And then subtract in the third one. Okay, so now definitely want to use a calculator here. So we're going to do 2 divided by -1.5. So that'll be negative, we'll call it -1.3. It was -1.3 repeating. And then the second one is 1 divided by 2.25. That'll be 4/9. So now we're going to do we're going to add those together. This would be -4/3, which is times 3/12, plus 4/9. This is -12, and that'll be -8/9. So then the 4 divided by -4.5, that is -8/9. So yeah, it's a little tedious if you don't have a calculator, so make sure you have one handy for the check. So that means we're good. That means -2.5 is 100% our answer. Okay, let's scroll down. Hit up at least 2 more examples. Go to the page where it says Irrational Assignment A. So make sure you don't write too big here. This requires a lot of work. So we want to factor the denominators. The only thing that can be factored, bottom right, that's a difference of squares. So now for the LCD, we have we got a y plus 3. We got this y here. This one's accounted for already, but we have a y minus 3. So we got 3 parts to it. So now we go back and we look and we go, okay, the shortcut is you can ignore the denominators now. We're going to decide what the 6 is going to multiply by. So what's here that's missing here? You can see it's the y and the y minus 3. So that's what the 6 will multiply by. 6y times y minus 3. So we're going to distribute. 6y times y is 6y squared. And then 6y times -3 is minus 18y. Okay, now on to the 2. So we get a y down here. What's missing? It's missing a y plus 3 and a y minus 3. So that's what the 2 is going to multiply by. So we're going to have to FOIL and then times 2. So carry over the 2. FOIL first, outer, inside, And then last, these two to cancel, 2 times y squared, then it becomes 2 times y squared, and then 2 times -9. A lot of writing here. All right, and then the equal sign, and then we are looking at the 5y minus 3. So what's missing here that appears here? Fortunately, it's just the y. So we're going to multiply 5y times 3 times 5y minus 3 times y. So y times 5y is 5y squared. Y times -3 is -3y. All right, finally, all that multiplying is done. Now to solve this. Well, let's combine like terms on the left. 6y plus 2y is 8y. Bring these down. Now, this is a quadratic equation because it has an exponent of 2, so we may have up to 2 answers here. So let's, when we have a quadratic, let's set it equal to 0. So subtract 5y squared and add 3y. So we have an equals 0. Okay. Now to keep solving this, you can factor quadratic formula. I notice everything can divide by 3, so I'm going to do that to make life a little easier on me. So what it does is it just gets y squared, nothing in front of the y squared, which makes it easier to factor. And that's what I'm going to do now. So we get a -6 for the c term, so that's a plus minus. 2 numbers that multiply to get -6 and subtract to get -5, that would be -6 and +1. And now I can finally go get what my answers are. Remember, you set your answers equal to 0, and then you solve them. So the first one you subtract y to get -1. The second one you add 6 to get 6. All right. Unfortunately, I'm going to have to invade the space of number 6 to do my checks. I'm going to first check -1 in the original problem. Remember, this is called checking for extraneous solutions. So the first one will be 6 divided by 2 is 3. Second one is -2. And that'll subtract to get 1 on the left. On the right side, it'll be -8 divided by -8 is 1, so -1 works. So I can confidently say -1 is an answer. Now I'm going to test out the 6. So this will be 6 over 9, which is 2/3. 2/6 is 1/3. Add them and you get 3/3, which is 1. All right, on the right, 5 times 6 is 30, -3 is 27. And And then on the bottom, 6 squared is 36, minus 9 is 27, and this does check out also, so both of these are answers. Remember, if you were to have one that doesn't check out, you would have to cross it out, and then it's called an extraneous solution. Okay, let's go down. Trying to think what I want to do. Let me do number 6. I'm going to make some room here. So I want to factor the denominators. The only one that can be factored is the one all the way to the right. We can factor out a GCF of x. So x squared divided by x is x. 2x divided by x is 2. So now onto my LCD. So I got an x plus 2. After that, I have this x here, which also appears here, so only put it once. And there's my GCF. Sorry, not GCF, LCD. So now I go, okay, what am I going to multiply the 3x by? Well, we have an x plus 2 here. We have it here, so don't worry about that. We're missing an x. So the 3x is going to multiply by x. So 3x times x is 3x squared. Next, what's the 6 going to multiply by? We have what's here, or what's missing here, that is over here, just the x plus 2. So the x will multiply by x plus 2. So 6 times x and 6 times 2. And equals. Now what's the 12 going to multiply by? So here is the same thing as here. There's nothing missing. So the 12 doesn't have to multiply by anything. So just bring it down. Okay, so let's solve this. We have another quadratic, so it can have up to 2 answers here. Let's set this equal to 0. So subtract 12. It actually cancels here and here. All right, how can I solve this? We actually have a GCF here. We have a GCF of 3x. So then divide everything by 3x to have 1x plus 2. Easy GCF problem. So now it's factored. We can get our 2 answers now. Set our each factor equal to 0. And we're going to solve. The first one divide by 3, so you'll have x is 0. Second one subtract 2, and x is negative 2. Or so we think, because now we have to do our checks. Definitely running out of room here. All right, so I'm going to check 0. So I'm going to try to save some space here. Just listen carefully. For the first fraction, 3 times 0 is 0. On the bottom of it, 0 plus 2 is 2. So that's going to be 0 for the first fraction. Then 6 divided by 0. Well, that's not okay. That's undefined. Therefore, 0 is an extraneous solution. We got to get rid of it. It's called an extraneous solution. All right, now we're going to check negative 2. The first fraction, 3 times negative 2 is negative 6. And the denominator, negative 2 plus 2 is 0. We have another error here, okay? So negative 2 does not work out. We have another extraneous solution here. So this problem, you actually have no solution. No solution. And that's the end of part 2.